Okay, we're now going to answer the conundrum faced by the stunning research team of Fabio Cardone out of Italy. Fabio Cardone is somebody I cite in my 2012 book. He's been doing ultrasound, what they're calling piezonuclear reactions. And at first, this was difficult for me to believe. I mean, I believed it, but obviously, it's not explained by standard science. And he started doing these experiments in the 90s, actually in the 80s, and so he's devoted his whole career to this research, and he's had people do PhDs under him or in his research team. So Ridolfi was another early researcher in this area. So in Italy, they've been funded by the military, and they use a patented technology, patented experimental setup. So that's part of the problem in replicating their results. And so they have encountered a conundrum that is explained by noncommutativity. So I just want to go into that a bit. But in my book, I mentioned they use a sonotrode, which is basically an ultrasound emission device. And this is just super fascinating research because it totally corroborates the ultrasound in quantum biology. That's sort of a crossover between mechanical and quantum coherence through the piezoelectric, but they're saying this is what they're calling piezonuclear. So how do you explain this? The occurrence of pressure-induced nuclear reactions is inferred, while the cavities are suggested to act as nuclear microreactors. The presence of new elements within the cratered, damaged zones on the ferrite surface can be attributed to the catastrophic collapse of the subsurface pore walls resulting from microexplosions, which correspond to the emission of aperiodic intense beams having a very short lifespan and different chronological structure, rather than continuous emissions of particles. The energy, speed, or better, the energy density and time whereby it is possible to break Lorentz invariance. This constraint has been verified in preceding works dealing with the time interval transformation for the hadronic interaction. Finally, one has to take into account the anisotropy and the asymmetry of the energy diffusion when Lorentz invariance is broken. For the hadronic interaction, the anisotropy is a consequence of the hadronic metric, generally anisotropic, which is described as function of the energy, as widely shown in previous works about the geometrical representation of the interactions in DSR. So they're calling this deformed space-time. I think that R was a typo, but they even have a textbook about it. But they're saying you're getting this superluminal energy that's a fifth dimension to the 4 dimensions of relativistic space-time. So they're saying that space-time is inherently curved, and so you end up getting this basically like a nuclear fusion wormhole on the microscopic level. So ultrasounds applied to aqueous solutions. In that case, a phenomenon of cavitation takes place, and the bubble implosion is accompanied by a shock wave able to concentrate the energy that was deposited in the bubble surface region into a volume of atomic dimensions. That abrupt energy concentration was evaluated, and it was considered sufficient to trigger nuclear reactions. By following that opened way, a parallel phenomenon was suggested to occur in solid matrices. In particular, in the case of iron irradiated by ultrasounds, the micrometric cavities already existing inside the sample were proposed to play the same role as the bubbles inside the liquid. The locally isotropic pressure induced by the ultrasonic front wave and the consequent implosion of the gases included in the cavities can create an effect similar to that proposed in the bubbles. The material's micropores exposed to ultrasonic pressure waves, resulting in an energy density to time ratio large enough to overcome the threshold predicted by the deformed space-time theory, triggering in this way a new kind of nuclear reaction. The large number of highly deformed cavities inside the sample containing the damage mark strongly supports the piezonuclear hypothesis. In fact, the maximum size is consistent with the theoretical calculations of the space-time deformation induced by cavitation. According to these calculations, the 19 watts of power of the ultrasound applied to the bar transferred over 370 I don't know if that's giga-electron volts of energy to the internal cavities, guaranteeing their collapse and the triggering of subsequent piezonuclear reactions. One of the most important consequences of obtaining the nuclear emissions is that the transformations of elements into other elements, could be obtained at relatively low energy. Okay, so that's pretty much in a nutshell what they're doing with these experiments that they've been doing for the past, 35 years. And they've demonstrated reduction of radiation, stabilization of radiation, changing the decay rate of radiation, and transmutation of elements, the production of alpha particles, demonstrating nuclear transmutation, and so they go over that. So this is a great corroboration of what happens in meditation, because you have this intense piezoelectric pressure that then would cause this nuclear transmutation to take place. So this variation can be created by the ultrasounds in the matter, thus allowing reactions that cannot occur in a flat Minkowskian spacetime. So they're assuming that their spacetime is deformed inherently. The suitable sudden variation of energy density can induce a local deformation of spacetime. So this is the conundrum that they encounter, that then I propose that non-commutativity can explain it So then somebody does their PhD on this pretty recently, and they've done like, I don't know, probably like a dozen different kind of experiments demonstrating by treating the radioactive nuclei via the deformed hadronic spacetime, it transforms them into stable ones, and hence reduces the activity of the solutions more quickly and less dangerously than would happen through natural radioactive decay. So their goal is to try to reduce radioactive particles. When a bubble collapses its content, which has a pressure of orders of magnitude lower than the external, escapes from the volume of the bubble to the outside. Well, those atoms trapped in the surface of the bubble are forcefully pushed into a spherical space whose volume becomes smaller and smaller, down to a radius that can be comparable with the nuclear radius. So when the wavelength is much bigger than the bubble radius, which is just the case for the numbers given above. Okay, so the bubbles contained in a liquid at room temperature have a radius in the order of 10 to the minus 6. Okay, the speed of sound in water is on the order of 10 to the third meters per second. And if the frequency of the ultrasound is 10 to the 4 hertz, or that's like kilohertz, the corresponding wavelength is 10 to the negative 1 meters. The bubbles contained in a liquid at room temperature have a radius of 10 to the negative 6 meters. In order to have the bubble implode symmetrically, the ultrasound has to be converted into a symmetrical spherical shock wave on the bubble's surface. This occurs when the wavelength is much bigger than the bubble radius, which is just the case for the numbers given above. So, okay, it kind of makes sense. Since the power density on the bubble surface can grow to values of which corresponds to a low density plasma with a temperature of 10 to the 20 something kelvins. This power density allows a high ion fusion like process. Okay, so this means this process takes place in a deformed space-time, which contributes to the dynamics of the process by absorbing the energy that otherwise would be emitted as gamma photons. So you're basically creating this micro black hole, wormhole, quantum wormhole, because it's deformed space-time with superluminal energy. Yeah, so we'd have to get there. I'd have to get his textbook to really learn all the details, but basically you have an extra energy dimension created by this difference between the surface area of the bubble that expands faster than the volume, or the volume collapses faster than the surface area. So that's what's happening. When you have that difference, then you get a space-time inversion. So here's another experiment, and superluminal propagation of electromagnetic waves. The energy is absorbed to deform spacetime. Thus, no gamma radiation is detected. Okay, so sometimes they get these asymmetric bursts of energy, and okay, so yeah, so the conundrum is this: why is it an asymmetric burst of energy? And they can have either fusion or fission based on, they're using iron. Iron is kind of the bridge between fusion and fission. Fission reactions transform heavier nuclei into lighter ones, but not lighter than iron. Fusion reactions transform lighter nuclei into heavier ones, but not heavier than iron. Thus, iron is the final limit for any chain of these transformations. Deformed spacetime reactions. Iron takes part in the process and facilitates it. So it's pretty fascinating, because that fits in with the alchemy use of iron, metal. Okay, so this research was presented as part of the Vigier symposium. And Vigier, he worked at the Stanford Linear Accelerator Center, and so at this symposium was also a talk by Lou Kaufman on noncommutativity, and also Brian Josephson got the Vigier Award at this symposium. So it was great. It was like this amazing confluence of researchers that I've studied, and I correspond with Brian Josephson, and he said he's not interested in non-commutativity. And so the emission of the neutrons is not uniform in energy, so you have this time asynchrony and spatial asymmetry. Okay, so here's some of the studies they've done. 2005, 1995. I found a study in 1980, sometime in the 80s was the earliest one I could find. Under suitable conditions of geometry and energy density in time, power, and space, pressure, which corresponds to energy in unit volume, the confined particle can become free, either because a threshold is crossed, thus changing the metric parameters of the spacetime, or because the used geometry corresponds to that of the deformed spacetime of one interaction, thus producing those effects characteristic of deformed spacetime. According to DST theory, the energy usually is taken away by the gamma radiation in these cases is used to deform the spacetime. Through the DST transformations, it is possible to change the atomic weight of matter without using ionizing radiations and avoiding radionuclide production. Okay, so super fascinating stuff. Now here's where it gets interesting. They mention non-commutative geometries, but they don't really focus on it. And then they also see, this is how I first learned about it. He's calling it the hollow wave of the photon as associated to the deformation of spacetime. And that concept of the hollow wave of the photon is directly from Vigier. So Vigier connected that to noncommutativity, worked with Luke Hoffman on it about noncommutativity. So they didn't seem to pick up that secret that it's actually due to noncommutativity. And so that kind of gives away where I'm going with this, because then they say in 2015, he says there's no apparent reason for connection between the asymmetrical neutron emissions and any macroscopic characteristics of asymmetry or inhomogeneity in the system constituted by the steel bar ultrasound generator. In conclusion, we are going in further forthcoming works to test the correspondence between the Lorentz violation asymmetry and neutron emission asymmetry by another class of phenomena in order to get more stringent evidences of the fact that the DST deformed spacetime conditions generated by Lorentz violation are intimately connected with asymmetry as a fundamental feature. So my whole point here is that the ultrasound itself is actually due to this asymmetric space-time or time frequency. So they're basically, because they're wrongly assuming that the way you measure time and frequency is a symmetric measurement. If they just realize that the foundation of reality is inherently an asymmetric time frequency as the source of the ultrasound, then that would explain the asymmetric emissions of neutrons and pulses. Let's see if I'm up here. I highlighted it. So that's my basic. That's what I was getting at, which is pretty obvious, but it's kind of nice to have some experimental. The asymmetry of the energy diffusion. I guess that would be the protons, the alpha particles again. The emission aperiodic intense beams. Yeah, okay. So that's pretty much all I have to say about this. And yeah, like I said, it's nice to have corroboration of the whole ultrasound theory as a quantum black hole, superluminal energy transmutation. Anyway, it's pretty much all I'm going to say right now. And I created a playlist of the talks that they gave. Some of them are just in Italian, but some of them are in English. So I will post the playlist. And yeah, it's pretty exciting stuff.